Welcome back! Today we're going to be working on the Pythagorean theorem in the coordinate plane. Our content objective is students will be able to use the Pythagorean theorem to find the distance between 2 points in the coordinate plane. Our language objective is students will be able to explain how to find the distance between 2 points using the Pythagorean theorem. And last but not least, why am I learning this? Well, it's important for real-world problems like finding the distance from one place to another. So first we got to go over some background knowledge. It's very important for you to understand that we're only allowed to use the Pythagorean theorem if we have a right triangle. And again, the Pythagorean theorem is simple as a squared plus b squared equals c squared. I also want to go over a previous example that we've gone over from our last lesson. So here it says a car drives 9 miles due east, so you would draw an image of that. And then it says, and then 12 miles south, so draw a picture of that. How far is the car from its starting point? So it's essentially wanting us to figure out the hypotenuse. And since it is a right triangle, I am able to use the Pythagorean theorem. Since x is the hypotenuse, 9 and 12 are the legs, so I'm going to plug it into my formula, solve, and find that the missing distance is 15. So to answer the question, how far is the car from its starting point? I would say the car is 15 miles from the starting point. Okay, so now what's going to happen is I'm going to go ahead and give you another word problem. In fact, this one's going to be read out to you verbally, and I'm expecting you to go ahead and map out the course for the given problem. So let's begin.
Roland went on a hike to visit a cave in the mountains. To begin his hike, he faced west and hiked for 3 miles.
So notice I went ahead and had a figure that popped up facing towards the west. It did just mention that he is traveling 3 miles to the west. So I'm going to go ahead and show that he's moving towards the left direction, 3 miles. Notice I'm using each individual box to represent a mile. Okay, so now continuing on with the audio.
Then he turned to the south and traveled for 2 miles.
So I'm going to go ahead and now have him traveling south, which is downwards, 2 miles. So there's 2 miles.
After a water break, Roland again continued west for 4 miles.
So again, since it's west, I'm going to be moving towards the left for 4 miles. So there's 1, 2, 3, 4 miles.
Turning north, he continued for 3 miles.
So now north is up, so I'm going to go ahead and have him moving up 3 miles north. 1, 2, 3.
Next, Roland turned left for 2 miles.
So left, I'm just going to go ahead and show that he's moving towards the left. So that would be 1, 2. So notice here, there's nothing difficult about it. I'm just following instructions and having him move a certain path that I'm being told to do.
And then took a right and continued on his hike for a final 6 miles.
So notice it says to the right. Does it mean he turned back? No. So at this point, if you think about it, if he's facing in this direction, if he's moving to the right for 6 miles, imagine that he is facing that direction. So the right would go in this direction. 1, 2, 3, 4, 5, 6.
Until you discover the location of the cave. How far is the cave from where Roland started his hike?
Okay, so this is where he is now. And this is where he started. So how far is it in between? So now, there are 2 ways to figure out this distance. You can go ahead and create a right triangle. There's 2 of them that you can look at. You can look at this right triangle right here that is being created to represent the distance. Or, here's your right angle. Or you could be using this right triangle. But no matter which one you choose, you're going to find that the distance is going to be exactly the same. I'm just going to go ahead and use this green one just because it's not mixed in with the red route that I drew in. So here, one of the legs of the triangle is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Okay, which in this case would technically be miles. And then here, it's going to be 1, 2, 3, 4, 5, 6, 7 units. But according to the context of the problem, I'm just going to go ahead and put miles. So the distance that they want me to find is from where he is to where he originally started with. I'm going to go ahead and call that D for distance. So notice, since I have a right triangle, I'm allowed to use the Pythagorean theorem. I'm going to go ahead and call D the hypotenuse. So therefore, 9 and 7 are the legs. So using my formula, Pythagorean theorem, which is a squared plus b squared equals c squared, I'm going to go ahead and plug in 9 for A, 7 for B, and D for c squared. So that's going to give me 81 plus 49 equals D squared. 81 plus 49 is 130. 130 equals D squared. I'm not quite done yet. I'm going to have to take the square root of both sides, leaving me with approximately 11.4. So to answer the question, I would say Roland is approximately 11.4 miles away from where he started. So notice the only thing that was a little bit challenging about this particular problem is there was more than just two directions. He took a certain path and you had to figure out his entire route. And then other than that, we just went ahead and used the Pythagorean theorem to figure out the actual length that he traveled. Okay, so now we're just going to go ahead and move on to the next problem. So here now it's just going to be a little bit more straightforward. It says find the distance between the given points. So here we have 2 points. We have 9, 0 and 1, -6. So all you're going to have to do is go ahead and graph. So here, since it's 9, 0, you're going to go over 9. And then since it's 0, you're going to stay here and plot your first point. The next one is 1, -6. So you go over 1 and then down 6. And there's your other point. So this is the distance that they're asking you to find. So in order to do that, notice you're treating this as the hypotenuse of the right triangle. So let's create a right triangle. Here we go. So now this is going to create a right triangle. So all you're going to have to do is figure out the lengths of the legs, because that's easy to do based off of this coordinate plane. I'm going to say this leg is 8 and this leg is 6. Now you have to be very careful because a lot of students like to count lines, so they'll miscount it and say 1, 2, 3, 4, 5, 6, 7, 8, 9, when in actuality you should be counting the squares to see how many squares make up the entire length or height. So in this case, if you think about it, 1, 2, 3, 4, 5, 6, 7, 8 total squares were used to represent this entire width of this triangle. So please, instead of counting lines, count the amount of squares. Okay, so now that I figured that out, I'm just going to go ahead and label the third third length, which I'm going to call whatever variable I want. Since we're using Pythagorean theorem and it is the hypotenuse, I'm going to go ahead and label it C. So of course, this is my hypotenuse, so I'm going to go ahead and plug in 8 and 6 for the legs, leaving me with 6 squared plus 8 squared equals c squared. I'm going to simplify what I have. 6 squared is 36, 8 squared is 64, leaving me with 100 equals c squared. I'm not quite done yet. I need to take the square root of both sides, leaving me with 10 equals c, or c equals 10 units. So what's the distance between these 2 points? I would say it is 10 units. So here, this can be replaced now with 10. So there's nothing too crazy about this one other than the fact that now you're graphing it. You just got to make sure you're counting the lengths correctly by counting the boxes and not the lines. And you're good to go. So on that note, I'd like you to go ahead and pause the video and try number 2 on your own. Okay, so let's see how well we did. First, we should graph. So over 8 to the left, up 3 is our first point. And then to the right, 4, down 2 is our second point. I'm just going to go ahead and connect those 2 points. This is essentially going to represent the hypotenuse of our right triangle. So let's create that right triangle. Here, we're going to call this 1, 2, 3, 4, 5, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yet again, notice I'm counting, in this case, the rectangles to see how many rectangles make up the height or the width of the triangle. And since I don't know this side and it is the hypotenuse, I'm just going to go ahead and call it C. Okay, so obviously this is my hypotenuse. I'm going to plug it into my formula for the Pythagorean theorem, and I should be left with 13 units. Okay, so this is essentially 13. So notice when you don't have a unit, you can always use the word units as your final answer for the units. Okay, now moving on. So those two examples were nice, perfect squares. Now what do we do if they're not? So let's check it out. For number 3, we're given the same instructions to find the distance between the given points. I'm going to go ahead and plot the 2 points. 2, 5 is my first one, and then 6, 9 is my second one. I'm going to connect those 2 points. This is essentially going to represent the hypotenuse of my right triangle. But now I need to create one. So here we go. So real quick before I move on, please understand this would have been another option to use for a right triangle. Whichever one you draw, you're still going to end up with the same answer, so don't worry if yours doesn't look exactly the same as your partner's. Okay, now that I've created my right triangle, I'm just going to mark that I do have a right triangle. The length of this is 1, 2, 3, 4, and this is 1, 2, 3, 4 as well. So here, this is my hypotenuse, and for the sake of using Pythagorean theorem, let's just go ahead and call that missing side C. I'm going to plug it into the Pythagorean theorem. 4 squared plus 4 squared equals C squared. 4 squared is 16, so we have 16 plus 16 equals C squared. Please be very careful. I do have a lot of students saying 4 squared is 8. That's a very common mistake because they're, instead of doing 4 times 4, they're doing 4 times 2. So just be very careful. 16 plus 16 is 32. We have 32 equals C squared, and take the square root of both sides. Now here, since it's not a perfect square, you're going to have to approximate to the nearest tenth. I'm just going to go ahead and give you the answer. I'm going to say C is approximately 5.7 units. Now, if you need help with approximating the square roots of a radical, please refer to the previous lesson. We did go over how we would do that. So please watch that if you need it. Okay, so now on that note, let's go ahead and try one more example. It says find the distance between the 2 points, between the given points. First, let's go ahead and plot the points. 6, 1 is our first one, and negative 3, 4 is the second one. Connecting those 2 points, that is essentially the hypotenuse. So let's go ahead and create a right triangle. This is the one that I went with, but again, there's another one that you could have chosen. Whichever one you choose, you're still going to end up with the same answer. I'm going to go ahead and draw in my right angle here. So here the height is 1, 2, 3, and the length is 1, 2, 3, 4, 5, 6, 7, 8, 9. So here this is the hypotenuse, and since we're using the Pythagorean theorem, let's just go ahead and call it C. Plugging it into the Pythagorean theorem, I'm going to have 3 squared plus 9 squared equals C squared. 9 plus 81 equals C squared. Then leaving us with 90 equals C squared. I'm not quite done. I need to take the square root of both sides to isolate C, leaving me with the square root of 90. Since the square root of 90 is not a perfect square, we're going to have to, again, estimate to the nearest tenth. So I'm going to go ahead and figure that out all for you already and say that C is approximately 9.5 units. Okay, 9.5 units. So now what's going to happen is I'm going to have you pause the video and try numbers 5 and 6 on your own. Okay, so let's see how we did for number 5. You would plot your 2 points, draw a line, and then go ahead and create a right triangle. This is the one that I came up with. Then you're going to go ahead and measure the different lengths. This is 6, this is 2, and then go ahead and plug it into the Pythagorean theorem. Okay, so in this case, I called C the hypotenuse, so plugging it in, I'm going to get 6 squared plus 2 squared equals C squared. 36 plus 4 equals C squared. 40 equals C squared. In order to isolate C, we're going to have to take the square root of both sides, leaving us with approximately 6.3 units. So here it says approximately 6.3 units. Okay. So now let's go ahead and check number 6 as well. Again, you're just going to go ahead and plot the 2 points together, draw your line, and then create a right triangle. And the reason why we're purposely creating these right triangles is because we would like to use the Pythagorean theorem. And we're able to figure out the length and the width based off of our coordinate plane. So it's definitely helpful. So here, calculating the length and width of the triangle, we're going to go ahead and label, in this case, the hypotenuse as C. Please understand you can choose whatever variable you want. I'm just choosing C for the purpose that I know it's going to be plugged into the Pythagorean theorem, so it kind of correlates really easily. But understand you can use whatever variable you want. So I'm going to go ahead and plug in my legs for the right triangle, which is 5 and 7. Leaving me with 7 squared plus 5 squared equals C squared, which is 49 plus 25 equals C squared. Simplifying it again, I'm going to end up with 74 equals C squared. We're not quite finished. We're going to have to take the square root of both sides to isolate C. So we have the square root of 74 equals C. Approximating to the nearest tenth, you should have ended up with C is approximately 8.6 units. So that is actually going to conclude our lesson for today. Please, if you do need help on approximating radicals that are not perfect squares, please refer to the previous lesson. We do go over the steps on how to do that. Thank you so much for tuning in, and as always, until next time, bye.